All right, so for this question, we are trying to figure out the confidence interval. All right, so we are given a sample size of 9, the weight of 12,645 pounds, the standard deviation is 20, and the confidence interval is 99% confidence interval. All right, so I'm going to try to clarify when you're going to be using the T table versus the Z table. All right. So here, this is basically what's going on. Everything it would depend from the sigma, whether it's known or unknown, right? So the fact here, if sigma is known, so that means that we know sigma, all right? If sigma is unknown, all right, is known, then we are not going to use sigma, we're going to use S instead, all right? So S and sigma, they are both of them standard deviations. However, this is a sample standard deviation, sample standard deviation, and this would be the population standard deviation. All right, so if you don't know sigma, you're going to use the t-test right away. Now, even knowing sigma, there is an extra conditions that you need to verify, which is whether the n is greater than 30 or not. So you can use the Z table only under the condition that n is greater or equal. You can put even equal sign. N is greater or equal than 30. Then you can use the Z distribution. If this one is wrong, then you're going to go back again and use a T distribution. So in conclusion, you're going to be using the T test if sigma is not known, or all right, or one of both. All right, so either this one or as well, or n is less than 30. So there are two conditions here. So either one of them will qualify you to use the t-test. All right. However, in order to use the z-test, you need two things. You need the sigma is to be known, and here a statement. So there are two conditions that they have to be verified, and n is greater or equal than 30. All right, so if we don't have the and, then we're going to use the t-test. All right, I hope this clarifies everything. Now for the calculation, the only thing going to change, I'm going to explain it in function of error. So the error here would be equals to t alpha over 2 times s divided by radical n. All right, so this is your error. However, if you're using the z-test, the error still almost the same thing, but is instead of t is z alpha over 2. Instead of s, you're going to be sigma and divided by radical n. All right, so that's the only thing that changed between the calculations, right, beside the table. So this is the formula that will be changing. I will show you later on in the example how we're going to use the E, right? All right, so for our example, we have a sample of 9. So that means that n is going to be equals to 9. We can define the degree of freedom. It's going to be n minus 1, which is 8. All right, from there. Now, next we have the weight is 12,645. So which means that's it's going to be the x bar actually. So this is x bar, it's going to be 12,645. All right. This is really important. They are saying the standard deviation for the sample. All right, so they mention what sample is 20 pounds. So because they say for the sample, then this is S, is not sigma. All right, so S is going to be 20, and then we can tell here the 99% confidence interval, so that's going to be C. All right, so if you are giving C, so therefore alpha will be equals to 1 minus C, and this is going to be 0.001. Oh, sorry. It's going to be, so alpha is going to be 0.01. All right. Now, how can I use all this information? Remember, you are looking for T alpha over 2. All right. So you are interested in looking for the E, which is equals to T alpha over 2 times the S divided by radical N. And obviously here we are using the T distribution for the simple reason that we don't know sigma. We know only the sample S. So automatically we are using the T test. All right. Okay, so how can I get T alpha over 2, and what is T alpha over 2? So if I had, this is my T distribution here. All right, so this is the T distribution. Here you're going to be 0. So the question is, if I have 99% in the middle, all right, so 0.99 here in the middle, what will be the value of T alpha over 2 here? What will be? All right, remember this is minus T alpha over 2. All right, so in order to do this, I think the easiest way is to determine this area over here. All right, so if I know this area over here, I will be able to use a calculator. Or here you're gonna imply that's alpha over 2, and whatever is 1 minus C over 2 basically, and I can use it. It's gonna be 1 minus the confidence interval divided by 2, and this is gonna be 0.0050. All right, so once I get this, once I get degree of freedom as well, I get the area, I'm ready to find my T value. All right, so use the calculator. I go second, vars, and then I go to number 4 to find inverse T, and this I'm going to put the area, which is 0.005. All right, and degree of freedom it would be 8, and that's all. I paste it, enter, and remember, so this is going to be minus 3.3553. Remember that you want to round 3 decimal places, all right, for the T value, so this is going to be 3.355. all right. So then if I go to my error, this is going to be 3.355 multiplied by the S, which is 20, divided by radical 9, and let's try to do this. So it's going to be 3.355 times 20 and divided by radical 9, which is 3. Enter, and this is going to be 22.367. all right, so now what I'm going to do with this, let me try to do another graph and explain it once I found the error. This is my X bar, and we have a normal distribution. We know the middle here, which is X bar, this is 12,645. And we are trying to find the ends, or these two ends of the 99 percentile. So if I knew this is 99% of my graph in the middle, 0.99, so this is 0.99, and what I'm looking for, I am looking for two boundaries. So I am looking for the X bar, the lower end, which is this point here. All right, the lower of the 99%, and I am looking for the X bar, the upper end. All right, so now what is E? In fact, E, what we calculated earlier, is the distance from the X bar to the upper end, which is E here, is equal to T alpha over 2 times the S divided by radical N. All right, and if I want to find the upper end, this would be too simply equals to X bar plus the error E. All right, similar way we can verify this is E as well here. And if I'm looking for the lower end, this will be equals to X bar minus E. All right, so we have the E, we have the X bar. So E, by the way, here is going to be 22.367, and we can do the calculation, I think. All right, so let's see. The first one is going to be 12,645 minus 22.367, and this is going to give you 12,620. All right, I need to round it to the whole number, so it's going to be 23. All right, so that's the first one. And the second one is going to be the same expression, just plus in between, so I can copy and change this is plus and enter. And this is going to be 12,667. All right, rounded to the whole number. So what is the mean? An estimation of the mean is going to be in between. This is the formula is between X plus E and X bar minus E. So finally, an estimation is going to be the 99% confidence interval is going to be between 12,623 and 12,667. All right, so let's go back to the question, try to plug it in and verify. So this one here is going to be 12,623, and this one is going to be 12,667. Let's check it, and it did work out. All right, so it seems like they want us to put a comma in between, but it's fine. All right.